So the pitch tonight is well, it's really all dimensional modelling. If you've been doing a bit of dimensional modelling in your role, you know about facts, you know about dimensions, you know about star schemas. You're in about the right place for tonight's presentation. So, without further ado, one more ado. The venue. Thank you very much to NAB for supplying the bowl here, magnificent venue, and we've got a bunch of NAB people here as well as a bunch of DWS people. So, welcome everyone. All right, on with the show. So, we've got a lot to get through tonight. First of all, we're going to do a little bit of revision. We're going to talk about data marts, facts and dimensions. We talked about those last time we met, but we're just doing a little bit of revision, make sure we're all on the same page there. We're going to go deeper into slowly changing dimensions. We talked very briefly about those last time. We know that there's three types, type 1, 2 and 3. Type 1's easy, we'll gloss over that, but we'll look at a little bit more deeply at types 2 and 3. We're going to look at some special cases of dimensions. Dimensions behave a little bit different, not quite the way that you'd expect. And we're going to look at some special cases of facts. Before now we've been looking, excuse me, we've been looking mostly at facts that are simple, discrete, point-in-time measurements. There's other types of facts, we're going to explore those in a bit more detail. Okay. Still on the revision side, we need to understand what a star schema is, or in Ralph Kimball's nomenclature, a data mart. So a star schema involves one fact table, that's the fact table in the middle. The fact table contains the measures, numerical measures, usually additive, like number of units or amount tendered. And there is one row in the fact table per measure or per measurement. Around the outside of the fact table we have the dimensions. The dimensions are the descriptive attributes that describe the fact. So in this example we've got stores, products, customers and dates as our dimensions. That's a star schema. It's one fact, many dimensions. Simple as that. Alright, a star schema becomes not a star schema when we snowflake it. Right? Now this is an example here of a snowflake dimension. What we've done is we've taken our store dimension and we've got the hierarchical attributes. So stores roll up into divisions, stores roll up into regions, and we've normalised those hierarchical attributes. Right? So now division and region, these are tables in our database, division and region are now more than one step removed from the fact table. This is a very tempting design for us because we're usually trained to normalise our data models, and when we see all of those hierarchical attributes sitting in the store dimension, we go, oh, well, that doesn't look quite right. All those dozens and dozens, or maybe 100 attributes in the one table, looks a bit weird. Let's normalise. Okay, but in a star schema, we don't normalise those hierarchical attributes because they don't serve our purposes. The purpose that we build the star schema in the first place is for performance and understandability. Okay? Normalising hierarchical attributes, or snowflaking in this case, doesn't assist in either of those ends. It doesn't assist in performance, it doesn't assist in understandability. In fact, it hinders in both of those. That's why we don't do it. If you're in a lecture and Ralph Kimball was up here talking to you, he'd give you a much more serious serve than I have on snowflaking. He's very passionate about snowflaking and avoiding it, to the point of giving special names to all of the cases where you can't avoid snowflaking. So Ralph never snowflakes. He might use outriggers, he might use bridge tables, he might use a couple other things, but he never ever snowflakes, and we'll talk about some of those later on as well. Alright, a fact table. So that was the star schema was the 40,000 foot view. Let's look in a little bit closer. What do we see in a fact table? Starting off at the top, we've got a primary key. Right, that primary key it's actually a surrogate key. It's allocated by the data warehouse. It's unique for the table, so one unique value per row, and it's allocated as the data is loaded into the table. It's completely meaningless outside of the data warehouse, and we never display it on a screen. Okay, then we've got a series of foreign keys. Those are foreign keys to those dimension tables that we had surrounding the fact table. A product key, customer key, date key, store key. Right? We start to get an idea that those dimensions are going to behave a little bit like the fact, that they'll have their own surrogate keys. Apart from the primary key, or the surrogate key if you like, the foreign keys, the only other thing we've got in there are the measures. Right? Measures are typically numeric, and they're typically additive. Things like sales amount or number of units sold are the sorts of things that we might see in measures. And that is all that we put in a fact table, except for the exceptions that I'll show you later on. Alright, dimension table. So zoom in on dimension table. What's in that? Once again, as I hinted a moment ago, we've got a surrogate key. So that's a key that we allocate as the data is loaded into the dimension, and it uniquely identifies a single row. Right, then we've got a source system natural key. I've bolded it there for you. That's the SKU number in this particular case. Right, so the product key here is what we use to uniquely identify a product. The SKU number is what the source system uses to uniquely identify a product. All of the other attributes there on a dimension are descriptive attributes, the sorts of attributes that a data warehouse user might want to display on a report or on analysis. That includes all of our hierarchical attributes that we can use to drill down and roll up all of our facts. Have that kind of colour? Yeah, good. How are we going in Sydney? Can you guys hear me? Yep, nod if you can. Yep, good. Okay, excellent. All right. How can we be sure that we don't rewrite history? All right. So when we looked at that dimension table a moment ago, it had lots of descriptive attributes there. We could quite easily, as changes to one of those products came in, we could easily overwrite the details of that product. Then, when we run a report, all of our old facts would start reporting differently. Now, the key technique that we use to make sure we don't rewrite history is, anyone? Help me out. Slightly changing dimensions. Which type? Who did that? Someone said that. Okay, type 2 slightly changing dimensions. Alright, so we're going to look a little bit closer at a type 2 slightly changing dimension. Here's an example here. We've got a product, we've allocated, the data warehouse has allocated a unique key of 1, 2, 3, 4, 5. The product is IntelliKids 1.0, and so this is straight out of Kimball's data warehouse toolkit, dimensional modelling toolkit. Okay, the IntelliKids 1.0 is a software package. It's sold by the education department, okay, and we start to get an idea here that department is one of those hierarchical attributes that we can use to roll up products. It's also got a natural key, a SKU number of ABC 922-Z. Okay, but there's been a change in the organisation. IntelliKids 1.0 was being, all of the sales of IntelliKids 1.0 were being rolled up to the education department. Decided we're creating a new department called the strategy department, and we're going to take a number of products, one of which is IntelliKids 1.0, and from now on we're going to roll up those products into the strategy department. Right. If we were to simply use a type 1 slightly changing dimension, what we would do is update this row. So we'd take row 1, 2, 3, 4, 5, we'd update education to strategy, and then all new facts that we get into the data warehouse, all new sales of IntelliKids 1.0 would report under the strategy department. But also all old sales of IntelliKids 1.0 would also report under the strategy department. That's not what we want. We want the old sales reporting under education, new sales reporting under strategy. So type 2 comes to the rescue. What we do is, rather than updating the row, which would be a type 1 slightly changed dimension, we add a new row to the table. So we can see that down the bottom there. We allocate a new product key, 25984, has nothing to do with the old product key, it's just the next number available to be allocated. Has the same product description and the same natural key. So you can also see that natural key is no longer unique in this table now that we've made it a type 2 slightly changed dimension. Okay, the department of the new row is of course strategy, department of the old row is education, and that's the key difference between the two rows. Now we do one other thing to this, is we note which row is the current row, because when new sales come in, we want to then those new sales have a SKU number of ABC 922-Z. We want to know which one to use. Okay, we don't want to use the old product. We want to attach new sales to the new product. So we put a star or a current row flag against the new product. But this causes a problem, because our feed of data, we're assuming all of the sales that come through in our sales fact are all new sales, so therefore should be allocated to the strategy department, to the product that rolls up to the strategy department. But what if we got a late arriving fact? What if we got a file? We missed a file a week ago, okay, and that file was all of sales from 1 week ago at a time when IntelliKids 1.0 belonged to the education department. So having our current row flag is not helping us anymore. If we took this new file, we loaded it up again and allocated all of the SKU numbers ABC 922-Z to the current row, they'd all be tagged against strategy, not against education. So what we need in addition to, or perhaps instead of, the current row flag is an effective and expiry date. So now we can take the date of our incoming sale and compare it to a date range on our type 2 slightly changed dimension. So rather than just blindly allocating it to the current row, we compare the dates and allocate it to the row that was active at the time that the, I'll get to it in just a minute, the row that was active at the time that the sale occurred. Okay, so it's not simply a matter of we get a new product, we get an old product in with a changed attribute and create a new row. Now we have to create a new row and update the old row because of the effective expiry dates, because the old row previously had an expiry date of an arbitrary future date like 31/12/9999. So what happened is, when we got the new row in this example here, we got the new row in on the 2nd of April, we updated the expiry date of the old row, we inserted the new row with an effective date, the same as that expiry date, and then end dated the new row at 31/12/9999. If in a week's time we got another new row, we would end date the current row and then insert a brand new row. And we would always have a contiguous period of time. So one row would go from here to here, next row from here to here, onwards up to the end of time. Now, so there's a question in the front.
2/4/13 sales, where would it go?
2/4/13 sales, so if there was a new row...
No. Expiry and effective.
Oh, okay. So we create a rule that for this particular example, what I would do, and my preference is that the expiry date is non-inclusive. Okay. So expiry date non-inclusive. Any sales that occurred on the 2nd of April would go to the new row.
Future arriving facts.
Future arriving facts, okay. So your question is actually out of scope of the intermediate dimensional modelling. It's an advanced dimensional modelling topic. Future arriving, you don't really have future arriving facts, but you do have late arriving dimensions that could impact facts in the future. Not a topic I'm going to go into tonight. But suffice to say, if you've got a dimension that comes in that would change future facts, you've got to update those facts. And it's not a nice thing to do. We try to avoid it. We try to push the matter under the carpet, but it doesn't go away. We have to update the facts. All right. So we just added 2 dates to our dimension. What do we put in those dates? Do we put in the system date of the data warehouse on the time that they arrived? Do we put in, if we've got a date stamp, the time that they were changed on the source system? Do we use that date? Or perhaps there's a business date on the incoming row. Business date says this change of department is effective on this particular day. It might be a day from a week ago. It might be a day from a month ago. Do we use that date? Okay, so business date, system date. Before answering that, let's ask another question on the screen here. So Joe's promoted to partner. He'll start earning commission on every job starting immediately. Should it matter when the promotion is entered into the system? Should it matter? No. So what does that mean? System dates or business dates? Business dates. Okay. We always for type 2 slightly changing dimensions use a business date. Sometimes the system date is the business date. Okay. Particularly with e-commerce type applications where end users or end customers are updating details directly into our database. That's the time at which they update it is the time at which it's effective. And it happens in a lot of cases. System date is very often the business date, but it's not always the case. And it's probably the single biggest error I see in data warehouses in the design of type 2 slightly changed dimensions, is we get in the habit of using system dates because of the absence of a business date. Often when we get data coming into a dimension, there's no dates on it at all, and we have to approximate a date for the type 2 slightly changing dimension, and we approximate that by the effective time of the file we receive. We receive a file overnight. It contains changes from the previous day, so I'll use that previous day's date as our business date for the type 2 slightly changed dimension, right? But that's a habit. Okay, if there is an actual business date on the row, or even if there's not, we need to ask the source systems: can we place an effective date against the changes that you're providing here? So always ask that question when you're building a type 2 slightly changed dimension. Don't simply build an ETL pattern that uses the ETL date or the current date and time of the from the data warehouse. Always check for a business date. All right, the precision of effective and expiry dates. We've talked in the example that I showed. We showed the precision of those effective and expiry dates to be only at the date level, not date and time. Uncle Ralph says that effective and expiry dates on type 2 slightly changed dimensions should be as accurate as possible, so accurate to the second, or even a lot of systems now capturing timestamps that are accurate to fractional seconds. So, if we follow the Kimball Group's suggestion there, then and no reason not to. We follow a lot of Kimball Group suggestions. That's why we're all here, after all. So we would make those effective and expiry dates accurate as close as we can to the second. But that advice it doesn't seem to me to be tempered with the knowledge that we're also looking for business dates, because apart from the case where the system date is the business date, I've never seen a business date that's accurate to the second. At best, it's only ever accurate to the day. So sure, look to make your effective and expiry dates as accurate as they can be made, but don't start making up accuracy that doesn't exist. Always look for those business dates. They may not be as accurate as the system date and time, but if they exist, they're actually what we want. Okay, as a result of using business dates, sometimes business dates aren't even accurate to the day. Sometimes they're only accurate to maybe the month, or maybe I've encountered one case where they're accurate only to the financial year. So if that's the case, if we've got a very coarse granularity in our business dates, we need to be prepared to not only when we get a new row or a change to our type 2 slightly changed dimension, we don't need to be prepared just to update the old, insert the new. We need to be prepared to update the current if it's for the same date period as the current row. So if we're just in the very simple case of our business data is only accurate to the day, okay, if we've got a near real-time ETL and we've got dozens or hundreds of updates coming in through the day, okay, we're not going, every single row we're not going to end date the old, insert the new, end date the old, insert the new, and have a dozen rows in there that have the same effective and expiry date. We're just going to keep updating the current row. And that can happen, and will happen much more if we've got even coarser granularity in our business dates. Okay, so type 1 slightly changed dimensions. We didn't really look at that very much, but that was just where we update the current row and we forget about the past. So we're seeing current facts against, we're seeing old facts against current dimensional attributes, or seeing the past in the present. Type 2, we're trying to more truly capture those past facts against past dimensional attributes. Are these the only two types of analyses that are interesting? For instance, can we see present facts against past dimensional attributes? And funnily enough, since I asked the question, the answer is of course yes. And that's where type 3 slightly changed dimensions come in. Okay, so back to our original example of IntelliKids 1.0. We've created a new department in the organisation called the Strategy Department. So this is a reorganisation of the business, and we've taken a group of products, including IntelliKids 1.0, and we've reallocated them from their original departments over to the Strategy Department. Right, so the top diagram there shows the current state. We've got product 1, 2, 3, 4, 5 in IntelliKids 1.0 currently against the education. Right? With type 2, we inserted a new row below that one. We're not going to do that this time. So using a type 3 approach, and remember with type 3 we want to be able to see present events against past dimensional attributes. What we're going to do is we're going to add a new column. Right? It's not something we can do on the fly, obviously. Our ETL code isn't going to just add a new column to the database and then start populating it. It's something we have to plan for up front. So our new column, or the column that we're using to handle our type 3 approach, is prior department there. So when the new row comes in, the new IntelliKids 1.0 says now belongs to the strategy department. We take the old department, we move it over to prior department, and then we take the newly arriving department of strategy and put that in the department column. So now we've still got just one row for product 1, 2, 3, 4, 5, or source system SKU ABC 922-Z, and we can take and all facts, old and new facts, will map to the same product as long as they came in for IntelliKids 1.0. So we can choose when we're writing our SQL or presenting our analysis from our BI tool, we can choose which attribute we want to use. Do we want to use the current one, or do we want to use the old one? Now this isn't always going to make sense. If we had IntelliKids 1.0, that was updated this week, and then we had a bunch of other products that were updated 3 weeks ago, and then a heap more products that were updated last year, you're not going to know what prior department means when you drag it into a report. It's just prior department, this is the one that was updated previously. This doesn't handle all situations. The times that we want to use a type 3 slightly changed dimension are different to the times that we want to use a type 2 slightly changed dimension. It doesn't handle all cases. Right? So when would we use one? Not a lot. I've seen one genuine use of a type 3 myself. It doesn't come up that often. So the most likely case is an organisational restructure. Like I said, there's a fixed point in time, like the organisation is changing at this point. From this time, the column prior department or pre-reorg department, if you like, will contain the old department. From now on, the new department, post-reorg, will be in this other column. And that way, when users are using the dimension, they know what they're getting. If they drag in prior department, they know they're getting pre-reorg values. If they drag in department, they know they're getting post-reorg values. The time that I've seen it used is in one of Australia's largest telecommunications providers, without providing any names. And there, it was in their product hierarchy and their cost centre hierarchy. They would change them financial year upon financial year. And in July, so they would present the new hierarchies in July, and for a period of a few weeks in July, while the new hierarchies were just being bedded down, they'd like to be able to run reports either under the new hierarchy or under the old hierarchy. And so we presented to them in their cost centre and their product hierarchies 2 sets of columns, dimensional attributes for current financial year, dimensional attributes for prior financial year. So then they could use the ones that they pleased. Once they'd bedded down, sort of halfway through July, everyone was happy with the new hierarchies, they'd start using them exclusively. Right, so we talked about one of the possible cases where we might use a type 3 slowly changing dimension is in a major reorganisation, such as a merger. I worked for a company once that went through like 5 or 6 mergers. So what would happen after when the second merger comes along? Would we get rid of the data from the old merger and just update it with so we only ever have 2 there, or would we keep 3, or would we keep 4 or 5? The choice is really up to you as a data modeler, but if you find yourself getting more than, say, 2 or 3 type 3 repeats of type 3 attributes, you might find that you're trying to do something that perhaps you shouldn't be trying to do. I can perhaps the reorg approach, or the merger thing, that might be a bit of a separate or a special case. I could see you entitling columns pre-company Z merger, pre-company Y merger. I could see that happening maybe, but I can't see that many managers actually interested in it. So I would. Type 3 comes along so infrequently that it's kind of a moot question. If it does come along, typically you'll only see one. I could imagine if you're doing it on financial year, like this telecommunications company that I won't mention, then the case was previous financial year. Arguably, you could say, well, previous financial year, we could extend that. We could go to the financial year minus 2, financial year minus 3. If you're doing that, I think type 3 is probably the wrong structure. If you want to extend it to, I want to report old and new facts against current financial year, or indeed any financial year that I name, structures from that year, then type 3 is not a good choice. I'd suggest maybe looking into a bridge table, which we're not going to cover tonight, as an advanced dimensional modelling approach. I don't think you'll come up against something like that, though. All right, the dimension of time, which of course is a misnomer. Ralph Kimball originally used time as the name of his date dimension. He found it too confusing for some people, though, and he's now using the term date, or the date dimension. Time had a nice ring to it. All right, the date dimension. Here's an example here. we've got a fact table there, it's got a date key, foreign key in it, and that foreign key points to a table that contains dates, 1 row per day. And each row contains all sorts of details about that day, and there's some there in the example. Most of those details can be easily calculated and populated ahead of time, so we can create our date dimension with perhaps the last 100 years of days in it, and maybe the next 100 years of days. It's not actually that much data. With 365 days a year, a couple of 100 years, still not that much data. Okay, so my first day in data warehousing, I had a look at this. I thought, dates in a table. I've never put dates in a table before. Didn't really understand why we're doing a date. So date's a date. You can work out pretty much anything you want to about the date by just looking at it. You know what month it belongs to. You know what week it belongs to. It's all quite straightforward. Can't we just use the functions that the database provides us to work all that out? We have to put these dates in a table. So there's some examples there of the sort of functions we might want to do. There's several reasons why we use a date dimension. One of them, we can't index all those possible functions. I know Oracle provides the ability to create function-based indexes, so we could create an index on, if we had a date in the fact table, we could create an index not only on the date itself, but we could create an index on a function over that date, like one of those, to-date, transaction date, comma day, so the day name. I could come up with an arbitrarily large number of possible functions that we could run over that date. Can we really index them all? If our fact table contains 1 billion rows, are we going to create, and I could easily stand here and rattle off 20 or 30 different possible and likely functions that the user might want to use to filter their query. Are we really going to create 20 or 30 indexes effectively on the same column over 1 billion rows? It's not scalable. It's not something that we can commit to. The date dimension solves that nicely. Because the date dimension is relatively small, it's really only a few 100,000 rows, even if you've got 100 years in there. We don't even need to. This is something that we can rip through a full table scan in under a second. So we don't really even need to index all of those functions, or if we put them in as explicit columns, we don't need to index them. All we need to have is on the fact table our date key indexed. Right? Once we've found the days in the date table that match our desired criteria, like April 2013, there's 30 of those in the date table. We take those 30 values and look them up in the fact table. One index on the fact table. Okay. Another good reason, second last dot point, it's hard to derive some attributes. Up the top there, there's a bunch of functions for things that are easy to derive. We can come up with things that are just a little bit difficult to derive. They're still possible, but the functions become more complex, like 445 weeks in a month, for instance. And then there's things that we simply can't derive with functions. So things like public holidays. They're just they're not amongst our list of functions, and date dimension nicely solves that. We can create things like a public holiday flag and any other business-related attributes we can put in the date table. All right, so date dimension. What about time? So if our date dimension is 1 row per day, what happens, especially in business these days? I can understand, if we go back 30 years, and things happen on a daily grind. That's not the case now. Things happen. We track things with timestamps. We capture data accurate to the millisecond, or even more accurate, microsecond, nanosecond. So date dimension is a little bit chunky at 1 day. Do we, if we want to do analytics on a lower grain, do we do that? Ralph's answer to that was a bit surprising to me. I had a bit of a double take, and I think this quote is taken directly out of the book. The finest grain of the date dimension is 1 day. finer grained divisions of time are not analytically interesting. I sat up pretty straight at that point. I said, ooh, but I've got this, and I don't know, I found that a highly contentious statement, but he provided a very rational explanation that I'm about to provide to you, and with very few exceptions, I think it's pretty good. So when we all read that, who actually thought that, yeah, a couple of hands, I've done. Who's actually created date or time dimensions that have a lower grain than the day? I have. Don't be afraid to stick up your hands, I've done it too. Okay, so I'm not saying you're wrong, but it's maybe there's another way to go about it. So let's have a look at that. So what about timestamps on drill-through reporting? The current system I'm working on here at NAB, we're doing a lot of drill-through reporting. Not so much analytics actually, mostly it's listing style reports. And we're interested in seeing individual atomic rows and the dates and times that those events occurred. So, and we've got this data accurate to the millisecond. What do you do with that data if your date dimension is only accurate to the day? So, I didn't say you couldn't store the date and time, or the timestamp. You can store that in the fact table as a secondary attribute. It's not used for analytics, and by analytics I mean rolling up and drilling down, but it is used for displaying data at the most atomic level. We can think of it like displaying our order number. Okay, something that's distinct at the very lowest level of analysis or drill throughs. So that's one possibility, and we'll talk about in a later slide the consequences of allowing this to go overboard and fattening out our fact table with all of these other possible attributes that we might only use for drill through reporting. What about durations in minutes and seconds? So we want to we've got two events that are accurate to the second or even finer, and we want to measure the duration between those two events. So that's kind of analytically interesting. This sort of thing happens all the time. But we want to measure things that only take a few seconds or a few minutes to occur. So the duration between measurements, or between facts, if you like, is a new measurement itself. So we don't necessarily store those two dates in the fact table. We calculate the duration in the ETL and store the duration in the fact table, okay, as a measure that we can add up. Next one. What about time of day banding? So we do analytics on our sales, where sales before 8 a.m. are in an off-peak period. 8 till 10 a.m. as a peak. 10 till 2 in the afternoon is off-peak. Then we go peak again, and we want to do analytics over these times of day. Is that not analytically interesting? Well, it is analytically interesting, but we're not talking about the day anymore, we're talking about the time of day. So midnight to 8 a.m. on a Monday is the same as midnight to 8 a.m. on a Tuesday. It's not date related, right? It's time of day related. And we might treat weekdays differently to weekends and differently again to public holidays. So we need all of the possible categories of time of day in our time of day dimension. So our date dimension is simply date. Our time of day dimension is whatever time frames that we're interested in. Probably the thing that should tip us off to needing a separate dimension is if we can imagine ourselves analysing over both at the same time. I want to see how activity in the peak period has changed month on month for the last 6 months. So we've got date, which is month in one direction. We've got time of day that we're measuring in another dimension. So we're actually using two dimensions at once. lastly, and this is the toughest one, globalisation. So depending on the time zone of the user, in fact, may belong to different dates. So if we're in Melbourne, then our day lasts from GMT plus 10 one day to GMT plus 10 the other day. If we're in India, our day is a different physical day. A single fact, depending on where we are, might roll up to a different day. So we can't just, a fact that occurred in Melbourne, we can't just tag it against one particular day, because depending on the user, it might roll up to any number of different days. So look, this is a tricky case. One possible solution is to create more rows in your date dimension. So a row for every hour, or if you want to handle South Australia, a row for every 30 minutes. If you want to handle Euclid in Western Australia, you can have a row for every 15 minutes. Then when the fact came in, depending on the 15-minute interval, you would allocate it to a particular row in your date dimension. But even though our date dimension now contains more rows at 15-minute intervals, it contains 96 times more rows than it did at the daily interval, it doesn't make it a date and time dimension. It's still a date dimension with a finer granularity. It's like our type 2 slowly changed dimensions. We had multiple rows in our type 2 slowly changed dimension that represented the same product. Now we've got multiple rows in our date dimension that handle the same day. Okay? What we haven't solved here is how to actually roll up and display facts by the user's day in the user's time zone. Not something that I'm going to go into here, but suffice to say that I'm willing to concede that globalisation is a case where you would have more than one row per day in the date dimension. Also worth noting that this approach to globalisation is not the Kimball approved approach. I'm not going to go into the Kimball approved approach because I think he's phoned it in a little bit. I don't think he's really solved it. All he did was talk about, we'll handle the system time zone and a base time zone like UTC, and that's it. We'll just handle two. So to me, it's not a globalisation solution. It's really just a dual time zone solution, and I think we need something more. All right, role playing. Dimensional role playing is something that happens. It can happen really with any dimension, but data is the thing that it happens to most. A sale is, since we've been talking about sales all night, a sale is a place where you would definitely see it. Date can behave in one of many ways on a sale, and if you look at the diagram here, we've got date behaving as a transaction date as well as a shipping date on the same sale. So this order was transacted on one day and shipped on a different day. So there's two separate foreign keys on the order. Do we need two separate date dimensions for that? Well, physically in the database, no, we don't need a separate date dimension for every possible context that we could use. But in our business intelligence tool, we do need to present multiple dimensions, because when a user is going through all of the attributes that they can present on a report and they see month name there, what does month name mean in the context of a transaction? Is it the transaction month or is it the shipped month? You can't tell. So when we're presenting our information model to users, we need to, where a dimension like the date dimension appears in multiple contexts or plays multiple roles, we need to present it multiple times. So in our database we'll have only one date dimension, but we might solve this with views, or in a lot of BI tools it'll be, the term they use is aliases. Okay, we'll have multiple aliases for the same dimension, a transaction date alias and a shipping date alias. Okay, so like I said, role-playing, we could probably come up with a few other dimensions that would play multiple roles in the same fact, or multiple roles across different facts where the dimension behaves slightly differently. Date is the thing that you'll definitely see it happening to, though. Righto, outriggers. This is one of those cases where where we allow snowflaking, but we don't call it snowflaking. Right, and once again, the date dimension is a classic where it happens all the time. So here we've got the fact coloured blue again. We've got a transaction date on the fact, and we've got a customer dimension attached to that fact. Now the customer dimension itself, it has a date on it, the date of birth of the customer. Not necessarily something that we'd want to analyse by month or anything like that, but yeah, maybe we do. Maybe there's some attributes on the date dimension that we want to use to do analytics on our customers. So we could find ourselves having a dimension on a dimension, but this violates our snowflaking rule. We don't want any dimensions to be more than one step away from our fact. Look, this is where Ralph draws the line on this. He says this is a valid case of not snowflaking. This is an outrigger. Okay, what we've got is we've got a dimension that is a dimension in its own right. This dimension attaches directly to facts. We're not just normalising the customer dimension here by attaching a date dimension to it. We're reusing something that we already have, being the date dimension. The problem is that once you open the door to outriggers, the temptation is to just go, well, actually there's some other hierarchical metrics on customer that I could probably outrigger out, and I might be able to use those sometime in the future and attach them to other facts, perhaps. I don't have any in mind now, but I can see that happening in the future. The temptation, our training leads us to attempt to normalise our dimensions. If you see yourself using outriggers more than a couple of times in a data model, outside of date where it's most likely going to occur, you've probably over-normalised a little bit. All right, outriggers. Okay, so that's it for dimensions. On to the different types of facts. And by different, I mean not discrete point-in-time facts. So we've talked about sales as if they happen at an exact time, and then that's it. That's the sale occurs, the product's sold, end of story. But in reality, that's not always all there is to a sale. We can go on and so we can raise the sale. We can send it off to shipping. Gets put on a truck, gets shipped. The customer receives it. The sale is closed. All this happens over a period of time. So we'll talk about that one in a minute. But the one we've got here is periodic snapshots. Periodic snapshot. Sometimes we have a fact that doesn't relate to an event that occurs. So once again, sale is a good example. Sale is an event that occurs. It's an interaction between the customer and the vendor. Something that occurs at a point in time. What about your bank balance? Right? We're interested in balances of an account, particularly at the end of a month or end of a billing cycle, perhaps. There's no event that occurs here. There's not a purchase or a deposit or withdrawal transaction that's specifically triggering this event. It's just the passage of time that triggers the event. So with a bank account, for instance, we might want to take a snapshot of the account and the account balance at the end of every month, or at the end of any given time period that we find interesting. When we take that snapshot, we put it into a fact table, and we put in a date dimension against it that reflects the granularity of that snapshot. It might be a monthly snapshot, so we have a date dimension that captures the month that we took the snapshot in. So key difference about periodic snapshot facts is we're not measuring event, we're measuring on the passage of time. The key thing about periodic snapshots that makes them different to transactional style facts is that the measures are semi-additive. So what I mean by semi-additive is we could take all of the accounts for the March snapshot, all of the customers whose accounts were snapshotted in March, and we could add up the account balance for all of those accounts. And that would make sense. That would be the total account balance of all of our customers. What we couldn't do is do that same addition over time. We couldn't add up all of the snapshots from January through to December and get a meaningful total over the year, because once we add January to February, these are two balances. They're not two transactions, right? So they don't add over time. They're non-additive over time. Right? What we can do over time is we could take a different aggregate function rather than sum. We could use average. We could use maximum, minimum, first or last. Okay. So when we create a periodic snapshot, we need to be careful when we're creating when we're defining that snapshot in our business intelligence tool, that we define the aggregation method over time to be we either disable it or we define a relevant aggregation method like maximum or minimum or first or last, but we can't use, they're not additive, so we can't use a sum as the aggregate method. Okay, touched on this a moment ago, accumulating snapshots. So what happens when our sale is not discrete? So we create the order, approve it, ship it, close it. These things happen over a period of time. They don't happen over like 2 minutes. So it's not going to happen all in the same day, and then we'll send the completed fact off to the data warehouse. These are going to come in dribs and drabs over the course of a week or a month or even longer. Accumulating snapshots can last years, potentially. Maybe not in a sale case. It would be a bit sad if we shipped it 3 years after we created the order. But so in the data warehouse, in the ETL, this is the accumulating snapshot is a case where we need to be able to update our fact. So the first time that order comes along, we're going to insert it into the fact table. The next time it comes along, it may have been approved, or it may have been approved and shipped, and we'll have new information against this order. It's changed from last time, and we'll update that information in the fact table. One of the key attributes of an accumulating snapshot is it tends to have a lot of date metrics, a lot of date foreign keys. There's an example there. So created date, approved date, shipped date, closed date. For each of these predictable progressions in the life cycle of the fact, we capture the date, and perhaps even the date and time that progression occurred. The progressions themselves might be of interest. So order events, all of the transitions between approval and shipped, or the transitions between shipped and closed, these might all be interesting. We might create another fact table that is a real event-based fact, a real transactional fact, not an accumulating snapshot at all, for all of the transitions. So then each order would have at least, say, 3 transitions: created to approved, approved to shipped, shipped to closed. That wouldn't be an accumulating snapshot. We'd create each of those 3 events in a transaction-based fact. So now we've got 2 facts measuring the same business process. We've got an accumulating snapshot that covers the entire order end to end, and we've got a transactional fact, a discrete point in time fact that covers the transitions between these predictable states. And that's not uncommon to have multiple facts tracking the same business process, because we're interested in different aspects of that business process. All right, degenerate dimensions. So we started off with our sale, and we took all of the descriptive attributes like product and customer and date and store. We moved all those descriptive attributes out into the dimensions. What we were left with was foreign keys and measures, as well as the surrogate key in our fact table. But there's one other thing that we haven't handled, and usually with something like an order or a sale, there's going to be on that fact as it comes from the source system, there's going to be some sort of source system primary key on that. We talked about dimensional primary keys, but we haven't talked about fact primary keys. On the source system, they identify that sale in some way. There's probably some sort of order number on there. We haven't put that order number anywhere. And the order number doesn't have any attributes that go with it, because we've taken all the other descriptive attributes and we've moved them out into dimensions. So we've just got this one thing left over, order number. So what do we do with that? Because we said that our fact table contained only foreign keys and measures, as well as the surrogate key. So what's this? What we could do is create a dimension that just had one column in it, order number, but it doesn't seem like a really worthwhile enterprise to migrate it out just to follow a rule that says we only have foreign keys and measures in our fact table. So we call this a degenerate dimension. It's arguably a dimensional attribute, but it doesn't live in a dimension, it lives in the fact table. Just leave it in the fact table. It's not interesting analytically, right? We don't roll up and drill down on the order number, but we do drill through on it. Once we've drilled down to a level of aggregation that's interesting to us, it might be 200 rows aggregated into this one metric on our in our analysis tool. Then we might want to say, well, I want to see those 200 rows, and we drill through and we display one row per row, one entry per row in the fact table, and we would want to at that point display the order number. So we use degenerate dimensions primarily for drill through, but they do serve one other purpose. I mentioned before we could have, especially with accumulating snapshots and periodic snapshots and transactional type facts, we could have multiple facts on the same business process. Those multiple facts could have the same degenerate dimension. They could all have order number, right? An order number can be used to drill across between different fact tables. We could do one analysis on the accumulating snapshot and then use the order numbers of the things that are interesting to us and drill across and show the transition events in the transactional event-based fact table using that degenerate dimension. So degenerate dimensions, useful for drill through, useful for drill across as well. David?
Also useful for count distinct.
Also useful for count distinct. There you go. So a number of distinct orders. If, assuming your fact table is, assuming that degenerate dimension is not unique in the fact table. That's not always, especially in the case of the event-based fact table that's one row per state transition. Right. Okay, degenerate dimension. So yeah, order number, cool. But my order also has a client reference number. So the client gives me a number that he uses to reference that order. And there's also a free text comments field where the data entry clerk can enter in comments related to the order. We also came up with that case earlier where we had the event date and time accurate to the millisecond. We're storing that in the fact table. Right now we've got 4 or more attributes that are all only useful, or mostly, not counting the order number case where we could drill across, they're only useful for drill throughs. So, especially once we throw in this comment text, we could have some quite wide fact rows. Remember, what we're trying to build here is a tool that can be used for analytics, a tool that can process lots of data and aggregate it up into interesting statements about our business. Should these analytic queries have to process all of this data? Because when you read a single row from a database table, you can't just leave behind. You can't just not read the bits that you're not interested in. Okay, you've got to read it all. So a fatter fact row means slower analytics, right? So look, I'd probably allow 1 or maybe 2 drill through attributes in a fact table. After that, I'd start migrating them off. So here's a case here where we've taken it's a dimension that's not really a dimension, not in an analytic sense. We don't use this dimension to drill down and roll up, but what we've done is we've migrated these drill through attributes off into another table. We've left our sales fact a little bit purer, a lot narrower, so that we can do less I/O when we do those analytic queries. When we do need those other attributes, we're only going to need them for a small number of rows, because a drill through, you're not going to drill through on 1,000,000 rows, you're going to drill through on a couple of hundred rows. Right? For those couple of hundred rows, then you do the join over to that order dimension. All right. Getting there. Oh, this is the last case actually. Master detail facts. Okay, this comes up a lot actually. Order and order line, invoice and invoice line. Who's encountered these in a data warehouse context? A master detail, yeah, a few of you, not surprising. Master detail type arrangement where the master has its own set of dimensions, the detail has its own set of dimensions, and we always want to do analytics on the combined set of dimensions and worse, the combined set of measures. So in this case here we've got our order. Our order contains multiple things. We want to order potentially many products. So the order line, it has a dimension of product. It's also attached to the order. The order itself has a store, a date and a customer that placed the order. The order also has its own measure. It's got an order discount amount because the discount is applied at the order level in this particular case. Down at the order line, that's where our more interesting measures are, the quantity ordered and the price or the amount tendered. So what do we do with that? Simple solution, roll everything down to the lowest level of granularity. So rather than have order and order line, or worse, trying to treat order as a dimension of order line, we take all of the order attributes, the order dimensions, roll them down to the order line. So now order line, which only had previously the product dimension, it now has store, date and customer. Okay, and it's got a degenerate dimension of order. Okay, our measures on the order line, we've still only got our the measures that were against the order line. We haven't solved the problem of what to do with those order level measures. So what about those order level measures? If you were to repeat that discount amount, that order discount amount against every single line, and then you tried to, on a query, add up the discount amount, you would end up double counting because it would be there for each item on the order. So we can't just repeat it. There really is only one good way of dealing with this, and the only way that Ralph Kimball approves of is to prorata that amount amongst the items on the order. So if we've got a $100 discount, we've got 5 items that, let's say there's 3 items that represent 10%, 20% and 70% of the order total, then we apportion that discount 10%, 20%, 70%. Okay, we need to come up with a way of dividing it up. And maybe that method doesn't make sense to the business. So we need to go to the business and say, well, give me a method that does make sense. Right? If they can't come up with a method that makes sense, then that's telling us that the only time that we're interested in looking at the discount is never at the same time as product. You're telling me that discount can't be seen at the same time as product because we can't allocate the discount across products. Right? So it's never interesting in the same query as product. So we can create another fact table. This fact table is at the order level rather than the order line level. Right? The fact table at the order level only has the customer and store and date dimensions. Okay, we can take the measures from the order line, we can roll them up, just add them up. Okay, we can leave the order level metric, the discount, where it is, but we can't have the product in there. Right, so we can end up with 2 fact tables. You'd have an order fact table and an order line fact table, both with as much as possible that can be placed in there. And we can use the degenerate dimension of order number to navigate between the two of them, to drill across between the two of them. All right, that is about it. So tonight we've looked at dimensions, we've looked at type 2s and the way we use business dates instead of system dates for our effective and expiry date in type 2. We've looked at type 3. Just because 3 is a bigger number than 2 doesn't make it better. Okay? Type 3 is used for very special occasions. It's not more flexible than Type 2. We don't use it instead of a Type 2. Okay, we use it for its own special purposes. Date dimensions and the way date dimensions behave for role-playing and outriggers. And facts, they're not just discrete transaction-based facts. We've got periodic snapshots and accumulating snapshots are other two big ones. We've also learned how to deal with master detail facts. We don't treat the master as a dimension. We roll attributes down, or if we absolutely have to, roll attributes up into the master. And acceptable cases where we have degenerate dimensions, where we have attributes in our fact that are neither measures nor foreign keys to dimensions. So that will get you, I reckon, about 75% of the way through any problem that you'll likely encounter in a real-world data warehouse. If you want to go the rest of the way, then you're going to need to study advanced dimensional modelling. I am proposing another presentation on advanced dimensional modelling. In addition to learning the techniques of advanced dimensional modelling, you will also need to use the techniques we've talked about tonight in the real world, and also practice these advanced techniques. And look, if you have a look at Kimball's book, it's a very big book. It's got lots of things in there. I'm picking out the things that I've encountered in real life and that you're likely to encounter in real life. For a more deeper analysis, you really should get the book and go and read it. But this is the next one I'm proposing to cover. Hybrid slightly changed dimensions, so not just type 1 or type 2 or type 3, but dimensions that behave in multiple ways at once. Once again, these Kimbalisms, mini dimensions, junk dimensions, bridge tables, he gives everything a name. Outriggers isn't the only one. Shrunken subsets and step dimensions, don't come across those that often, and coverage facts. Who would be interested in an advanced dimensional modelling presentation? So, that's great, excellent. That is all I have for you tonight. Thanks for coming and listening and being attentive. And by the show of hands, I'll see you all again next time. Are there any questions? David, again.
I've got a transactional system that does hard deletes. How would you handle it?
Transactional system that does hard deletes. And I won't tell you about it, the hard deletes. Know what you can do. This isn't the modeller's problem. It's the business's problem, and the business needs to come to the party with you. Okay. The ways that I can think to solve it are installing a change data capture package on the source system. So if the source system can't capture those deletes, you capture those deletes. Option number 2, don't deal with it. So don't capture the deletes. Say, well, look, you won't tell me what they are. Business won't invest in an infrastructure that tells me what's been deleted. There's nothing I can do about it. Okay, but it's your problem, not my problem. The other possible way is track it yourself. So you would need to track with a full extract from the system. Obviously, that can be very resource intensive, especially on the network. If you're doing a full extract over, so you might not need a full extract of history. Maybe what things can be deleted, perhaps the things in the current financial year. And then you use your ETL tool to compare tonight's snapshot to the previous full volume snapshot and work out the differences. Yeah, they're the only ways I know how to deal with it. But you really need to get buy-in from the business. If it's a problem that they want solved, then they shouldn't really have a problem with putting in change data capture on the source system.
Source system is a black box.
Yeah. So then. Yeah, it depends on how badly they want that problem solved. Anyone else? There were lots of questions last time. I must have answered them all in the presentation. Okay, well that's it. I'll see you all next time I get one of these things together. Thank you.
Thanks, Ross.